This video is going to serve as a review of solubility and temperature. In this video, we're going to discuss 4 questions. First being, what is dissolving, and looking particularly at the particle level. Second question is, what is solubility? Third, what happens to the particles of a substance when temperature is increased or decreased? And then finally, we're going to pull all this information together and answer the question, how does temperature affect solubility? And again, we're going to use look at the particle level to answer this question. So first off, what is dissolving? Well, we know that a solution is created by dissolving. And in a solution, they need to have something called a solvent, which does the dissolving. So here are the red particles, and that's the solvent. So in a liquid solution, the solvent would be the liquid. So water, remember, water is the universal solvent. The other part that needs to be in a solution is the solute, and that's the material that is dissolved. So in this case, let's pretend that the solute is going to be salt. We know that when we put salt in water, it is going to disappear, but we know, scientifically speaking, the salt doesn't actually disappear. There is no magical magic happening where it actually disappears. What's actually happening is the salt particles get broken down, and they end up filling the spaces between the solvent particles, which is water in this case. So what happens is, when they're broken down, the attraction of the salt particles to themselves gets decreased, and they become more attracted to the water. So they're just filling the spaces between those water particles or between the solvent particles. In a nutshell, that's what dissolving is. So a solute filling the spaces between the solvent particles. So they're not actually disappearing, it still exists within the solution. It's just the particles are filling the spaces between the solvent particles. Alright, what is solubility? Well, solubility can be thought of as the maximum amount of solute that can be dissolved by a solvent. So how much salt can I actually put in water before the water says, I don't want any more salt in there, and it can't dissolve anymore? What happens to the particles of substances when the temperature increases or decreases? Well, here is a pot of water, 2 pots of water, one of which is on a stove with the element being off, and the other one is on a stove with the element being on. So if we look at the particles and the spaces between these particles of the water, you'll notice that in the one that's just off, so probably room temperature water, or maybe it's cold water, the particle spaces there's still space between the particles of the water, because we know in a liquid there's space between the particles, and they're flowy, but they still are attracted to each other. When heat is added, what happens is the spaces between the particles get larger. So we know that the water, if we heat up water enough, it's going to turn into a gas, but it doesn't go straight from a liquid to a gas. You have to heat it up. So what's happening when you heat it up is the particles are going farther apart from each other. So the water particles are going farther apart. Now, that's if we increase the temperature. So if we look and we decrease the temperature, we can look and notice that the particles would get closer together. So increasing the temperature, they get farther apart. Decreasing the temperature, they end up getting closer together. Alright, so now what does this mean for solubility and temperature, and how temperature affects solubility. Well, we know solubility is the maximum amount of a solute, that can fit into a solvent or get dissolved by a solvent. So, when we look at it, if we had a beaker of water at 20 degrees, you see that the particles are close together but not super close together. And at 80 degrees, they are farther apart. The particles are farther apart. So, if we look at it, which beaker would have more space to fill? Well, if we look at it, the spaces between the cold room temperature water particles, it's not that far apart. So the less space there is, the less particles are going to be able to fit in there. Now remember, this isn't an exact, accurate representation, but it gives you the idea. So we could fit that many particles in that water. In 80 degrees temperature, on the other hand, we can fit more particles in those spaces. Now, the size of particles, they should technically be the same as in the room temperature, but the amount is a lot more, right? I can fill these spaces with a lot of particles. So, therefore, increasing the temperature of a solvent will increase the amount of solute that can go into or be dissolved. So therefore, an increase in temperature equals an increase in solubility. And vice versa. A decrease in temp equals a decrease in solubility. Now, this is because of the spaces between the solvent. So, again, higher temperature equals more space between the particles. More space between. A lower temperature means less space between. We know that if we have more space between, we can put more stuff in it. If we have less space between, we can put less solute in it. So, that is a summary of how temperature affects solubility. Make sure when you're explaining how temperature affects solubility that you do talk about the spaces between the particles and what is happening at the particle level. This is key to explaining the scientific background behind what is actually happening. And be as specific as you possibly can. Try not to use stuff like I did a little bit in this video. Use solvent, use particles, use more spaces. Explain your answer.